All right, so for 29, it says a projectile is fired over level ground and has an initial velocity of 28 meters per second. It is in the air for 2.5 seconds. What is the x component of the velocity? So I have a little drawing here, and the initial velocity coming out is um, 28 or 20.8 meters per second. Now remember that that resultant vector can be broken up into two components. You can have your velocity in the x direction, which is what they're asking us. That's what we don't know. And then there's also the velocity in the y direction, which would go this way. And both of these are initial, and we don't know what they are. Um, so this is the initial fact. So that remember that our maximum height or our y value is equal to the initial velocity in the y direction times time minus 1/2 times g, the acceleration due to gravity, times time squared. Oh, and I forgot. We know that the time that this is in the air is 2.5 seconds. So because it's on level ground, that tells us that at the beginning and at the end, it's going to land over here somewhere, right? So our final y position then would be 0 meters above the ground. So we're going to let this be 0 meters in the y direction. Going up would be a positive value. We're not going to have any negative y values. So it goes, the path of the projectile is going to go up, 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 reach a maximum height, and land right here. And it's going to do that in 2.5 seconds. So, that means if we plug that in, there's a couple of things that we need to do. One is we got to find y, the velocity in the y direction. Okay? So one thing that we could do is, I know what g is, right? We know that g is 9.8, right? So I could plug that in here. We know what the final y is. We know what t is. We could plug all that in and find the initial velocity in the y direction. So let's do that. So I'm going to say y, which is 0 meters. I'm just plugging that into here. By naught, okay, times time, which is 2.5 minus 1/2 times 9.8 times 2.5 squared. Okay. So when I do that, mathematically what happens is this becomes 0. This becomes 2.5 times by naught. This becomes negative 4.9 times whatever 2. I feel like that's going to be like 6.25 or something, but let's just do it on the calculator just to be sure. So we're going to say Desmos. We'll do a scientific calculator. So we're just going to say 2.5 squared. Yep, 6.25. And then we're going to multiply that by negative 4.9. and we get negative 30.625. So this whole thing here becomes negative 30.625. Whoops, why am I doing it that way? I'm just going decimal crazy over here. 625, and this is 0. That's equal to 2.5 V naught. Going to add this to both sides, and I get 30.625 is equal to 2.5 V naught. Divide by 2.5. Divide by 2.5. There's a point in here, a decimal. So I'm going to take this number, and now I'm going to divide that. So then I'm going to divide that by, so we'll say negative 30.625 divided by 2.5, and I get negative 'kay, somewhere I think I made a mistake. Oh, I did. It's 2.5. Whew, that's better. So we get about 12.3 in the y direction. Now, we got a negative because I forgot that when I move it over to the other side, it becomes positive. So it's about 12.3. That's what if we round that. So then our y velocity is about 12.3 meters per second. So I just realized I did this whole thing in blue. So let's change this around. So that's the y velocity, right? Vy is equal to 12.3 meters per second. This is meters per second. And what we really want is we want to know the y. Okay? So the y then we'll have to calculate separately. Or, I'm sorry, the x. The x naught. So remember that the relationship between these is that v oops, wrong one. V naught is equal to, V naught squared is equal to Vx naught squared plus Vy naught squared. Yeah. So then if you take the square root of both sides, well, actually, we're going to solve for V naught. So really, I say V naught minus V sub y squared is equal to V sub x squared. That's an x. Let me fix that. I'm trying to hurry up, and I don't need to. Vx0 squared. All right. Then you take the square root of both sides. So you get V naught squared minus V sub y naught squared is equal to V sub x. So then lastly, we're going to say 20.8 squared minus 12.3 squared, and then we take the square root of all that stuff, and that gives us V sub x. So let's do that real quick. I'm going to say the square root of 20.8 squared minus 12.3 squared. And when I hit enter, I get about 16.77, so we'll say it's about 17 meters per second. That's the x component of the initial velocity. So up here we would say approximately 17 meters per second. That's the answer. Okay.